That's the time promised here on the slide. So let's get started here. So hi, everybody. Welcome to today's Presto Tech Talk. Super excited to get started here. So by way of introduction, I'm Allie. I'm part of the Presto Outreach Committee. So work closely with many of the community members. So excited to have our March Tech Talk today. So before I hand things over to our presenters, just a few kind of updates and things going on in the community. So first of all, just a reminder, many of you are probably already in one of these meetups, but if not, we have a lot of local meetups. So feel free to join those. We have Bay Area, New York City, London, Bangalore, and Sydney, and we'll be doing hopefully some more in-person stuff this year as the world has started to open up a bit more. So that's the plan. Highly encourage you to join the local meetups to get to know other Presto community members in your area. And then of course, if you're not already a part of the mailing list, you can do that. Add yourself to the mailing list where we send out all updates on meetups and conferences and kind of anything going on in the Presto community. So feel free to add yourself to the list using that link. So with that, what are we talking about today? I'm excited to have Srini and Seb join us today. They're going to be giving an introduction to Presto and Superset. So with that, I'm going to send things over to Srini, who is going to get us started. Srini, please take it away.
Hey, thanks for the warm welcome. Hey, everyone. Happy Wednesday. I guess it might be Thursday in some parts of the world. So I'll start by sharing my screen. Hope everyone can see this. And let's enter slideshow mode. Cool. So I'm excited to be here. This is the first Presto Tech Talk I think I've given. Full disclosure, I am new to the Presto community and just Presto in general. And so this was a fun learning experience for me as well. And so here's kind of an overview of what I plan to talk about today. So I'll start by giving a little bit of context on Superset, some of the origin story, why it exists, some of the use cases for Presto and Superset, and really where these two open source projects shine together well. A demo of some of the core workflows, so you can get a sense for how Superset's actually being used with a real kind of Presto engine actually running. Talk a little bit about kind of what's needed for the Presto Superset integration. So we have this thing called database engine, and so I'll kind of talk about what that is in the Superset context, and then also hint at kind of the future of Superset, where the project is going. And just kind of talk about the kind of coming plans for 2022, and hopefully some of that's relevant to the use cases that you have. So let me go to the next slide. So kind of a quick intro about myself. So I'm based in Boston. I've been in the data science industry for almost 10 years. So I started at a number of startups. This is actually my 5th startup. So I've kind of mostly only worked at startups because I really enjoy that type of feel. Before joining, I spent 5 years helping build a company called DataQuest. So we taught data science online through this interactive platform. So I'm really kind of passionate about getting more people using data tools and just thinking in kind of a more computationally literate way. And so that kind of got me excited about not just teaching the existing tools, but improving the tools themselves. So I joined Preset about 2 years ago. We're kind of the main driving force behind Apache Superset. And I'm also a committer and PMC member for the Superset project, which these are kind of Apache Software Foundation specific words, but they're basically just kind of signify that you have a lot of influence in the project, the open source project. So I spent a lot of my time focused on developer advocacy, doing talks like this, community documentation, and writing a lot of blog posts, which are all things I enjoy doing a lot. So first things first, what is Apache Superset? The way I kind of frame it is we're the world's most popular open source data visualization and BI platform out there. So within the open source space, there's really not a lot of BI tools left. Some of the existing ones that were popular have been acquired or shut down. And so we're kind of one of kind of just a handful of very popular BI platforms that are still out and still growing, and we're modern in the sense that we're using modern web technology. So unlike a lot of BI tools, we're kind of designed with the web in mind, with browser-based collaboration as kind of a standard. So we use technologies like Python 3 in the back end. We use TypeScript in the front end. And we're always looking to find ways to upgrade parts of that stack, which I'll talk a little bit more about later on in this presentation. Two, we work with nearly any SQL speaking data engine. So I think we have an unofficial list of 200 or 300 different SQL data engines in the broadest sense that Superset can plug into. This is primarily because of the bet on the abstraction layer of SQL Alchemy, which I'll talk about in a later slide as well. And lastly, for a Viz tool, for a BI tool, having a lot of charts is important, of course. So it's great that Superset just right out of the box ships with a large diversity of chart types. There's kind of over 60 base visualizations that ship with Superset. You can also build your own chart types if you're comfortable with the front end ecosystem. And each of these charts can be highly customized. So you kind of have a good coverage of a lot of the common charts that you see and the common charts that you kind of hope for in a BI tool. Let me go. So the origins of Superset. So the photo here is of a gentleman, Max Buchamin. So he was the original creator of both Apache Airflow and Apache Superset when he was at Airbnb. It's since obviously been spun out into the Apache Software Foundation. And the real driving force behind Superset was the frustrations that him and his team were having with Tableau. To be honest, I'm actually a big fan of Tableau. I think it's a great product. I kind of call it the Photoshop of data viz. But at the time, there was no support for Apache Druid or Presto. They've since added support, of course, but this was kind of a motivation for them to think about how can we build something that's a little bit more flexible, scalable, and isn't going to cost a ton of money per user per month, and also kind of embrace the web instead of kind of treating the web as an afterthought, really being designed from the web ground up and kind of with collaboration in mind. And so Max actually written a great kind of blog post on this. If people are interested, called "The Future of BI is Open Source." But so all this to say that Superset and Presto have always been hand in hand. One of the main motivations for Superset even existing is the fact that they were running a very large Presto deployment at Airbnb, and they were just kind of stuck in terms of the type of flexibility they wanted in their tooling. So the support between Presto and Superset has a very rich and long history, probably only pretty much parallel to Apache Druid. So both these backends have been really a big priority for the Superset community. So the kind of common use case that I think Presto and Superset both really shine at is this self-serve BI and analytics on top of a data lake. So in this demo, this is kind of a simple reference architecture that I'll be showcasing today. But of course, the backend you can replace any way you want. So if you want to add Hadoop, you can do that. I know that's not as popular anymore as it used to be. I definitely remember in the college days where that was all the rage. But I do know a lot of people do use just Hive Metastore directly in the Presto context. I'll be using MinIO in my demo just because it all works nicely locally. But all the ideas carry over perfectly to S3, Amazon S3, or the other cloud vendor equivalents, or kind of future file system technologies. And so the way that Superset talks into Presto is actually through Hive. And so there's a great library called PyHive that the Dropbox team has open sourced and still maintains. And then you'll see this kind of SQL Alchemy logo as well. And that's really because of the abstraction layer of SQL Alchemy that I kind of talked about before. So the interesting thing is that the whole goal of this abstraction is Superset kind of wants to treat every database and every backend kind of the same. And there's pros and cons to that, right? The main pro is that if you have a database that's able to conform to some common standards, 90% of the functionality just works. But then one of the cons, of course, is that if there's very specific functionality, then that has to be kind of manually extended. So some databases, for example, have a different time bucketing function, and that needs to kind of be extended and baked in. Otherwise, you might end up with kind of the default date trunc function, for example. So a little bit about the two main workflows in Superset. So I always like to talk about this because this is a little bit of the design philosophy for Superset. So we have what we call Explorer, which is the no-code chart builder. So this is, and I'll have screenshots of this, and obviously I'll be demoing all this very shortly, but it's kind of our no-code chart building experience. This is how we're able to generate queries on a user's behalf. And a lot of this is actually directly enabled by SQL Alchemy. So not only is SQL Alchemy kind of somewhat of a universal database connection interface for Superset, but it's also the UI elements of Explorer kind of map very cleanly to the SQL Alchemy properties. So if you're doing kind of a filter, if you're running the filter command, for example, then in the UI for Explorer, that's also shown to end users as filter, stuff like that. Same thing with group by, for example. So this is also one of the reasons why in SQL Alchemy, there are joins, but it's kind of done in a slightly different way sometimes. And in the no-code Explorer UI, for example, in Superset, there's currently no support for joins just because that's kind of a design decision. It's quite hard to support joins well if you're not kind of giving people that visual feedback. And then the second workflow we also have is SQL Lab. So if you are doing some type of crazy join, if you do need kind of the full power of SQL and you want to bring that to bear, SQL Lab is going to be probably the place where you spend more of your time. But the outputs of both of these tools are still kind of treated equally for when it comes to charting and visualization. So they kind of cater to two different personas. The no-code workflow caters more to what we call the explorer and consumer persona. So a busy data professional that's trying to get work done that kind of assumes some degree of cleanliness in the data. SQL Lab is more for the person who really wants to tinker and get into the weeds of the data set. So this is kind of a screenshot and a preview of what Explorer looks like. So as you kind of mutate and choose values on the left in the Explorer UI, then that kind of updates the query that Superset sends to the backend and does a round trip. And when you hit run, you get the chart that you're hopefully looking for. And there's also additional customization options as well. So kind of just a fun little slide on SQL Alchemy for people who are new to it. So from kind of Superset perspective, a query comes in from the Superset front end through the ORM. An expression is kind of generated, and then using the Python DB API, DB API 2.0 client. So any kind of driver that we work with, a database engine driver kind of needs both of this. It needs a SQL Alchemy dialect as well as a DB API 2.0 client, which basically kind of exposes this type of uniform API for Python. So what's an engine object? What's a connection object? What's a result object? That type of thing. So this is kind of a little bit behind the peek into the back end of Superset, but these two are kind of the key platform components that Superset needs. So enough talking. I'll kind of exit full screen and then show how this all works together. Just grab some water real quick. So here I have, I like to kind of start with the punchline first because it's more exciting that way. So here I have a dashboard of data on NBA players. So this is from the seasons 1950 to 2017. So it doesn't have some of the more recent kind of Steph Curry, data points. That's why you'll not see him as the top 3-point scorer, even though he is currently the top 3-point scorer. And so the way this basically works is this is kind of in Superset land. This is called a dashboard. Each dashboard is just kind of a many-to-many relation with charts. So you can make an arbitrary number of charts, and then you kind of pick each chart and you opt in to the dashboard that it actually belongs in. But ultimately, everything in Superset boils down to a query on some level. So if you look at this chart, which is what we call a table chart, this is just a query, and this is actually generated by Superset. So this is generated in the no-code experience. I did not write this query myself. So that's kind of just a little visual overview, and then I'll kind of dive in a little bit more to how the query is actually generated. So for this first chart, we have top 10 3-point scorers. So this is from the entire 1950 to 2017 range, who are the highest, who has the most number of 3 points. And so the way this works is essentially you have on the left a metadata browser. So for this table, this shows all the columns. You actually notice that a lot of them have ABC in front of them, and I'll get to why in a second. But this basically means that it's a varchar or a variable character type, which you don't really want obviously for numerical values, but I'll discuss in a second why it's like that. And here we have basically, obviously the raw data does not look like this. So if you want to look at the raw data, you can click the View Samples tab, and you can see the underlying data. So for it has data for every player for every season. So you'll see the same name obviously multiple times. You'll see their 2-point percentages change from year to year, so 1995, 1994. That type of thing. And so we don't want to show raw data necessarily, right? Because if you're looking at the top 3-point scorers, we actually need to aggregate that data. And so when you want to aggregate in Superset, you want to use a metric. And so this metric right here, this metric picker is kind of the main point of fulcrum for specifying how you want an aggregation to happen. And so you're kind of able to pick from any of the columns that you'd like. I have this very special handy dandy column called 3 points, which I'll explain why it's special. But for this demo, it's basically just another column, and then I'm basically summing it. And then the question is, how is this aggregation actually happening? A group by is also required. So depending on how I select the group by, the query that's generated is going to change. And as you iterate on these values, you will actually find that the query right here will change. So to show that, for example, I can change this to, let's say I want to change it to, I don't want to do a percentage, but we can do total points scored instead. All right, so you'll notice immediately the Superset detects that a query change has happened. Let's say I want to keep the nulls, right? Like, because we have data from 1950, there's some missing values from that time, and we'll even take off the sort for now. So we'll hit run query, and notice I did not write the query myself. It was written for me, and I can still view the query that's actually generated. So it's doing a select, it's doing a sum. You'll notice here that I'm actually casting this variable character column as an integer, which I'll get to in a second. But yeah, this is kind of the meat of the data set, and then it's doing the sum and the group by on top of that. Then if I like how this looks, I can hit save, publish to the dashboard. You kind of get the general idea. It's very common in a lot of BI tools. If I want to change the chart type, I just come here and I can pick from any number of chart types. Different charts have different requirements, of course. So in my case, I actually haven't specified a time column. So a lot of the time series charts won't actually work right out of the box. I need to kind of make sure that there is a time column. And so this is kind of the general flow for all the charts here. So even if you go to this other one here, you can kind of launch an Explorer workflow from any of the existing charts that you have. So in this one, I'm doing total points scored by team. Of course, New York Knicks are crushing it, 426,000 points in the lifetime. And I've also added some filters. And so these filters are kind of going to end up in the where clause in SQL. So you can kind of get a sense for how the values here map to different predicates in SQL. And so that's kind of a general demo, and then I'll kind of switch between specific concepts and go back to the live instance. Actually, one thing I did want to mention is a little bit about the architecture. So here I have Presto running locally at port 8080, and I have MinIO running here, which is kind of emulating what S3 or what a large data lake could look like. And it's a pretty simple setup. I have 2 folders, one with player data and one with player stats, and I have a CSV file in each of them. So basically, I just uploaded the data manually. You can imagine in a larger setting that you may not want any human actually touching the files in the data lake. It's going to be all kind of generated by computers, by code that's actually running different types of ETL jobs, placing the data here, and then using the Presto CLI, actually registering the data as data sets. So I can actually hop over here to look at what the underlying data looks like. So from here, this is what we call SQL Lab. This is kind of the SQL editor that I mentioned earlier. You come over here and pick the Presto database, which I've already set up. If you're using Superset through Docker Compose, we also do ship kind of an examples Postgres database. So Postgres is another database that also has a lot of good support in Superset just because it's used as part of testing, as part of the examples database. I don't recommend, of course, using Postgres for analytics, but it is there. And again, Superset just cares about SQL. It doesn't really care necessarily about the type of database you're using. So here I'm picking the schema. In this case, I've just stored both data sets in the default. I have two data sets on Kickstarter as well, but the two data sets in particular that I'm using are player data and season stats. So player data has data on individual players, their demographics, and season stats is their kind of seasonal performance. And so the rest of this is just kind of a usual SQL editor. And so the interesting thing here is that all these charts are actually powered by a join query that I've done because I need data on player stats as well as their season stats. So here I'm running a SQL query that's doing a right join between player data and season stats. So we get, in season stats, we have multiple rows and there's going to be multiple potential matches. So I do want that kind of bias towards the right table there. And then from here, what I can actually do is launch Explorer. So the way the no-code Explorer experience works in Superset is you can launch it directly from a physical data set, or you can run a query, save the result as a virtual data set, and then use that to power a query. And if you want to see what that looks like, this is kind of all the data sets that Superset is aware of. So Superset itself has a tiny metadata database that it maintains. So if you're running it purely natively, it's just a SQLite database file. If you're running it through Docker, most people use Postgres to store the metadata for Superset. And you can come in here and actually filter the data sets down by the database that you're connecting to. And you can see here that I have 4 physical data sets and a virtual data set as well. And if I click on the virtual data set, you'll notice that it's just a query, right? So that's kind of everything in Superset's a query. Superset thinks about all the databases very similarly. So it's really kind of nice and universal that way. So next I'll talk a little bit about the semantic layer. So the philosophy in the Superset community is we actually don't want to have a very thick semantic layer. So there are fantastic tools out there like Looker and Holistics and others that have an entire modeling language built into the BI tool. And we've kind of taken the exact opposite stance here for a few reasons. One is we're generally of the belief that the BI layer is actually completely getting unbundled. So tools like Looker or Tableau used to do a lot of things. They solved 10, 20 problems at once. And now you're actually finding that there's entire categories and companies taking just chunks of that. So for example, LookML, there's 8 competitors to LookML that are open source, and they're kind of now battling each other out in the arena of metrics layers or metrics repos. And so they're kind of disaggregating, disentangling the metrics layer from the BI tool and actually bringing it in kind of closer to the data stack to the back end so that it can actually power multiple potential front ends, and it also gives more flexibility to teams that want to switch tools, for example. So that's kind of some context, and I did write a little bit more about this. So if you go to the Preset blog, I wrote about how the semantic layer works and the philosophy there. But to give a kind of general picture here, we have basically 3 really simple metaphors. And in general, what I mean by thin semantic layer is we really view this feature set as last mile data preparation and data transformation for the specific purpose of visualization. So if you need to create a dashboard and rename the groups in a pie chart, for example, to be more contextual to a specific user or a specific customer, you may or may not, you probably don't want to make that change in your physical underlying database because that's going to then impact any chart that is backed by that physical table. So you can just, these kind of low compute, quick renames are great for our kind of superset semantic layer. So in that vein, we have something called a calculated column. So if you want to do a non-aggregated column transformation, like casting a column type from string to float, for example, which is something I definitely did in this demo, and I'll show in a second. Metrics. So I did sum by 3 points, for example, right across all the seasons. But if I find myself doing that multiple times, I can just publish that as a shared metric for the entire team or entire workspace to reuse. And lastly, we have virtual data sets, which I showcased as well, which is really just any arbitrary SQL query. With SQL Lab, with kind of these arbitrary SQL queries for virtual data sets, Superset will send them directly to your database for the most part. They're kind of mostly untouched. It does not go through the thick SQL Alchemy abstraction layer. So this is kind of the sandbox for doing more arbitrary, open-ended SQL queries that maybe only your database that you're using supports, or if you're taking Presto and then a common workflow is people taking that and then joining multiple databases that speak entirely different types of SQL. Superset may not know about all that, but it just knows that you made a query, it ran successfully against the SQL backend, and it was valid and has data. So as far as Superset's concerned, everything is good in the world. Viz types, I kind of previewed this a little bit, but we have a large diversity of visualizations in Superset. So we have a good kind of coverage. And the exciting thing here is actually the history of charts in Superset is in the early days, the charts were all built on NVD3, which is kind of a abstraction layer on top of D3. So you'll notice a theme here, a lot of abstraction going on. It's kind of one of the keys to building a generally useful BI tool is you do kind of need to pick the right abstraction layers. So NVD3 in the early days was good, but that community has kind of slowly dissipated and progress on the project has stalled. And since then, Alibaba has actually, I think it was Alibaba, yeah. They open sourced a fantastic library called Apache eCharts. Really, it was called eCharts, and then it went through the Apache Software Foundation. It actually graduated from ASF just a little bit later than Superset did. And that's an insanely popular charting library. It's very high performant. And you might be asking why D3 is not enough. And the reason is because D3 is pretty low level. I mean, D3 is not even a visualization library. Interesting. It's kind of not that well known, but D3 it's really just kind of a data shaping language. And then you can build charts with it. But if you need a little bit more overhead, if you need things like callbacks, D3 does not really support that. It's more of a lower level building block. And so you need something like NVD3, or you need a framework like Apache eCharts, something a little bit higher level to create more of that plug and play feel. So right now, half the charts are in NVD3 and Superset, half are in eCharts. But the goal for this year, kind of part of next year, is to move all charts over to eCharts, and definitely any net new charts that the community is adding are all written in eCharts. It's kind of a hard requirement because we no longer have any appetite for supporting NVD3, which is the past. The last thing, the last kind of interesting end user feature is dashboard filters. So here, any kind of dashboards. So the kind of three main metaphors in Superset are data sets, charts, and dashboards. A data set is just a query or a physical data set. A chart is powered by a data set, and a dashboard is a collection of charts. That's kind of the simplest way to think about it. And a dashboard filters are basically an additional layer of ability to add what I call dynamicness, or kind of end user dynamic experience to the dashboard. And so this lets you come in and create a bunch of charts for a specific context, and then kind of explode a few of the parameters as something that end users can actually use. And this is especially great in a world where you have a small focused area, a small focused team of people creating these types of dashboards and charts, and then you want to expose it more generally to a larger number of people, or, which I'll talk about in a second as well, if you're building a public kind of embedded dashboard, this type of workflow is also kind of really important. So here I have a few charts on top 3-point scorers, total points scored by team, and total points scored by position. Now, this is kind of a somewhat biased and filtered view, but because a lot of it is just shows the top 10. So if I want to actually focus the search space more towards a question that I have, I basically come here, click this pencil, and then I can add filters. So this is what we call dashboard native filters. So if you can actually believe it, back about a year ago, filters were actually a separate chart type. And so they were always felt kind of like a weird experience. And so this is kind of our revisited, redesigned native filters. And they're native because they actually live in dashboards at a higher level than just another chart in the dashboard. So that's kind of the context there. But here I can basically add filters that map to column types. So as I mentioned, I don't have any time columns currently, but I can pick a numerical range or a value. In this case, I have a filter for the NBA player's position. So then I just basically identify the data set, the column, and then I name the filter. And then there's some other nice stuff. You can do a hierarchical filter. So if you wanted to have a filter with all of the player names, but you want it to be faceted by team name first, for example, if you wanted to sort the filter values or have a pre-filter, if you only wanted to make 5 of the values available, all this is kind of completely possible. And then there's a scoping tab where you can choose which charts this filter will actually apply to. So to show this in action, let's look at all the centers in NBA history. And you can see that each of the chart is updating. And so, yeah, you'll notice some funky things. So this is kind of one of the challenges of dashboard design sometimes is if you make a dynamic experience, if you're building a highly dynamic dashboard, you want to make sure that, I call this a little bit of an error viz state, right? So if you're showing a tree map where you want to show proportions, but then there's only one group, the chart is not really that useful anymore. The rest of the charts are useful, of course, right? So if you're looking at top 3-point scorers, you can look at all the center players that are also high scorers. You can also look at totals. So this is kind of centers. This is center players scored by team, basically. So Detroit had a lot of centers, or a lot of high scoring centers, rather. And if you want to just look at total points scored by all centers, right? You can also do that right here with this table. So it's kind of one way to slice the data. Actually, before I finish, I was going to show that. So this is kind of abstraction all the way down, right? So even if I open this right here, and if I actually not even do, let's just do view query. If I do view query, you'll notice that position in C, right? So in the actual higher level query that was there before, once I added position, that was inserted into the where clause, the inner where clause for this data set. And so as any kind of changes that you make in the filters trickles down to the queries, that's what updates the charts, and that's kind of what is the foundation of a dashboard. So it's this kind of nice, a dashboard lifecycle is kind of one way to think about it. And of course, we can do the same thing for teams. So this is the null values. This is kind of that null value I was talking about. So I'm originally from Dallas, so I'm not really a big Mavericks fan, to be honest. I never understood the hype, but I'll put my hometown. Why not? So here I can see. So now we expect that total points scored by team will only represent one group, which is the Dallas Mavericks. The total points scored by position, of course, will change. As you expect, the power forwards and small forwards have the most number of points, and no surprise there, Dirk Nowitzki is the top scorer, both in threes and both in total points. So kind of a preview of dashboard filters. So here's kind of just a laundry list of other features. And so like one is Jinja templating, which I actually did an entire workshop on. And so this is basically the ability to add variables into queries. So Jinja is a Python framework and it's commonly used in the BI world and even by tools like dbt to take SQL queries and add curly braces, and then you can kind of augment the state of that query with dynamic values. So in Superset, you can take, for example, filter state from here and build queries with placeholder variables and have the filter state trickle in. So if you want to do some really complicated query that's powered by this type of user input here, you could do that. Or if you wanted to send people a dashboard and then the dashboard generate a different query based on who is logged in, you can take the user ID from the Jinja template macro and then feed that into your query. So it's a very powerful way to make their dashboards even more dynamic than you originally may have thought. I have support for alerts and reports. So if you want to get a Slack notification or an email when some threshold is hit, you can do that. We have a really powerful API. So if you go to superset.apache.org and go to our docs, you'll see we have an interactive API Explorer, support for custom viz plugins. At the end of the day, the plugins in Superset are all open source. They're all customizable. And we've made some big investments here to make this even easier. Dashboard filters, which I showcased. we have a very thin caching layer. So just like thin semantic layer, we're not a big fan of having a really thick caching layer. We think one of the challenges of a lot of the older school BI tools is having two levels of kind of data that's available. And as you know, BI tools, their expertise is not in caching, right? Database vendors, open source database creators, they're the experts of caching. And modern data lakes and data warehouses in general are very, very high performant. They can handle a lot larger volumes. So caching in general is just it's just not really as important. We do have thin caching. So if you just wanted to show the exact same static dashboard to a billion people, for example, there's definitely no need for that query to be run every single time. So if you just want cache behind a chart or a dashboard that is available in Superset, you just go into edit view and you can immediately set how aggressive you want the caching to be. So but it's very simple. It's not meant to support or kind of augment your database. It's just meant to take very much static data assets you create and just make that available to a lot of people without putting a lot of load on your database. We have Semantic Layer, which I showcased. In the future, where's Superset project moving in 2022? So one of the important visions that we have and the community has is we want everything to be available as code. And so in the BI world, people kind of talk about this as headless BI. Sometimes it's called dashboards as code. There's a number of framings for it, but essentially anything that's possible in the end user UI, we want to be able to be specified as code because then it can live as part of the software development lifecycle. So you can imagine that every data set, chart, and dashboard is actually created programmatically and is updated. So you can imagine kind of an Airflow job finishing, kind of updating data in your data lake, and then you have queries, Presto queries that run, and you want all these things to be timed and coordinated. And so you can kind of do this right now. It's a little bit painful. You have to use a combination of the Superset API and the Superset CLI. And so we have big plans to streamline all of this. Everything that's possible in the end user UI, we want to be possible programmatically. That's a big thing for us. Embedded, so we want people to be able to take charts and dashboards created in Superset and embed them in other applications. So if you've ever interacted with Slack Analytics, Lever Analytics, HubSpot Analytics, a lot of them actually are some type of Tableau or Looker embed, but just very much hidden. You don't see any branding, and it's kind of more behind the scenes. But a lot of the current embedding offerings are proprietary. So as an open source project, we want to kind of bring the power of open source here and make this much easier to do. And the cool thing here is that people are actually already doing it. One of our biggest growing use cases in the Superset open source community is people taking Superset, building entire products and platforms on top of it, and then exposing it to their users or their customers. So we want to make this easier, though. So that's important. Cross filtering, we do have basic cross filtering, but we want to take this to the next level, closer to kind of what Tableau or Power BI offer. We want Superset to work great on mobile. We probably will never have an app or anything like that. That's also complicated with open source, but I think just having it work better on your phone in a mobile browser is an aspiration. Dynamic viz plugins, so being able to quickly make charts and import them via the UI. Right now, if you wanted to make custom viz plugins, you have to kind of make an NPM package, publish it, and have it live as part of your bundling and CI process, which is a little bit more overhead than is nice. And lastly, we want to move all the default charts to eCharts. So it's kind of a little bit of the past, the current for Superset, as well as the future. So for people who want to set up something similar to what I've done, as I mentioned, I'm running everything locally. It's not really what I recommend. So I'm going to assume people here do have Presto running in some sense, either through a vendor or through their own open source hosting efforts. And so really there's two simple requirements. You just need PyHive in the same Python context as Superset. So Superset can be run through Docker. If you click onto our website, the Superset website, you'll see a few different installation options. If you just want to try it out quickly, Docker Compose is probably what I would recommend. Just have Docker installed on your computer, run this or clone Superset, run these two commands, and you'll have Superset up and running in under 30 seconds. From there, you want to make sure that you have PyHive installed in the same Python context. So all you really need to do there is to go to the second article where we talk about for every database, the different drivers. But you basically just need, in the same Python context, you need PyHive. So if you search on this page, right? So Apache Hive, and for Presto, you just need PyHive installed. And once you have it, the way you know that everything is working is if you go to databases, you will see, so this is kind of a pre-existing connection I have set up. You will see that I have Presto here, and you will see that, again, this is running locally at port 8080. And so you just need to type in a SQL Alchemy URI and hit test connection, and everything will work. Here's what it looks like from a new database screen. I'm running open source Superset, so I don't have any logos, but you can actually map. If you're running Superset and you want to put logos here or change the order of the logos here, you can do that as well. But you click Presto or you pick from here, and then you put in your SQL Alchemy URI. If you want to know what that looks like, you can go. We have a nice little page dedicated to Presto right here, and it tells you the connection string. So host name, port, database. For most databases, if you need like SSL or something like that, we do have this advanced tab where you can add more things. So I think for most databases, we have this like engine parameter extension where people link to their SSL certificate, or just to hard code the SSL URL, or the HTTPS URL rather. You can also enable things like asynchronous queries, and you can also enable DML. I'd be very careful with this. The goal of Superset is not for doing complex ETL or for manipulating data. BI tools are designed more for consumption. They are created more for creating charts and dashboards. It's not really a SQL IDE the way DataGrip or another full-on SQL IDE is. But hey, if you need to run an update command, you can enable DML and do that. There's also some nice things like query cost estimation is enabled if you want to do that. And you can also support CTAS and CVAS as well, if you'd like to do that. So that's pretty simple. Last thing, just for fun, for people who are real database geeks and database engine geeks. So all of our database engines live in a single folder in Superset called DB engine specs. So you'll find for every database, the specific engine. And Presto is one of the longest and most supported. And what do I mean by longest? It has a lot of custom supports. If you look at databases that we don't support that well, it'll be very short. So for example, I worked on this myself, the crate.py. This is 64 lines of code. It mostly relies on the SQL Alchemy dialect that the CrateDB folks have created, but it's really short. It doesn't do anything. It doesn't take advantage of all the niceties of CrateDB. It's only 64 lines of code. You'll look at Postgres, which is also well supported. You'll find 315 lines of code. I think Presto actually is one of the largest. We have over 1,000 lines. We have 1,200 lines of code. And so this means you can do a lot of nice things. So you can catch errors in Superset in SQL queries and expose a different error message. So error messages are not part of SQL Alchemy. There's no kind of universal specification there. So if you wanted to provide a better experience for people using Presto and Superset, you can kind of use these custom errors or add your own if you'd like. Same thing here, so update impersonation. There's almost 40 or 50 different special functions that are kind of optimized for Presto. For other databases, it'll just default to a generic implementation. So yeah, things are really well supported between Presto and Superset. And I think that's everything that I got today. So I'd love to see a large number of chat and Q&A, so I can dig into some of that.
Quite a number of questions that came in, but first, awesome presentation, Srini. That was great. And gosh, I had no idea the roots of Superset can be traced back to Presto to some extent. So that's so cool. So thanks for sharing that history. So with that, I'm going to go through. We got a bunch of Q&A both in the chat and that came in directly through the Q&A box. So why don't I just get started, Srini, here?
Sure.
Okay, so first question from Radha. Is there a way to restrict the number of schemas to display in Superset? We have Presto on top of Hadoop, and we do see kind of 200 plus schemas. We just would like to limit the schemas to say 10. Is that possible in Superset?
Yeah, it's a good question. So there's kind of two different views of this. So, and actually show this real quick. So in the dataset view, you actually, so there's kind of two extremes. So one extreme is SQL Lab, where this is meant to be for power users, right? This is really meant to unlock the full power of your database. So it's going to show every single schema in SQL Lab. However, but when you actually want to create charts or you want to expose a more end user friendly interface, the data sets that are shown here are opt-in. And so you can choose, so if we choose Presto, we pick a schema, these are data sets that I had to manually add. So I would say that even if you have a lot of schemas, when you're using Presto and Superset together, you may be better off just trying to filter, like having almost a completely separate schema potentially just for Superset. And I think if I recall correctly, the way I may have set up Presto here is I have a catalog. So I guess that's the right, again, I'm new to Presto, so I apologize. But so I have an entire catalog here called Rabbit Hole. I did not name it. It's just the images, the Docker image that I use. But we have a separate catalog. So anything that's not, so you can imagine having like a Superset catalog, for example, and then you can specify in the Presto level in your Presto installation which schemas you may want to use. So kind of a convoluted answer. If you just want a short answer, there's not really a way to restrict the schemas that are shown. This is kind of, again, part of the Superset philosophy, which is we want to avoid doing too many things if it can be done. Like a lot of these things are actually better done by the database tool itself. And so this is one of those decisions where the community is like, let's just actually make this, let's just let the database handle this instead of the front end, basically. So.
Cool. Great. Okay, next question. Dan asks, is it possible to integrate Folium, which is more focused on maps? It's a library that's yeah.
Sorry, which library in particular? I think I missed part of that.
Folium, F-O-L-I-U-M.
Oh, Folium. Yeah. Okay, I know the library. Yeah, not really. So right now, even though Superset's written in Python in the back end, the way charts work, charts are very much separate. And in fact, there's even we have a great engineer, Beta, who came from Lyft, and at Lyft they were using Superset, I believe, purely as a backend, right? They weren't even using the charting functionality; they were just using the data access layer, which kind of hints at the kind of a little bit of lack of coupling there. So basically, the way it works is the front end, any Viz plugins, they're all written in front end code. So there's no link to Python at all. The front end charts basically are receiving state from the back end, so query results from your database, and then they're transforming it. And so Max actually made a fun demo where you take results from a database and play a little Tetris game, because that's how separated they are. So with Folium, my understanding is that there's kind of a backend and a front end component. So you would need to build a pretty deep integration. Superset is open source, so if you wanted to learn it, you could do that. I wouldn't recommend it. But I think what you could do is, I believe Folium's front end is based on Leaflet potentially, or you might want to find another alternative. Then you can just take the front end JavaScript kind of Viz layer, and you can build a custom Viz plugin off of that. But there's no way, I come from the Python data world as well, and I've always wanted it, but there's no way in Superset architecture to really take a Python backend driven Viz language, even like Matplotlib or something else, and bring that into Superset. You have to start the other way. You have to start with the front end instead. So,
got it. Hope that answers your question, Dan. Next, Raghu asked, and I know Seb answered this, but Srini, maybe you can also add some color from your perspective. Can you elaborate more on the query flow? Because this connector provides many services. How does Superset replace connector services that I think go with different data sources that connect to different data?
So I know some people use Presto for kind of federated querying. That's obviously one of the popular use cases as well. So I would say there, as I kind of mentioned, hinted at earlier, right? So the Explorer, the no code experience is not really the best place for that. So if you wanted to query a Redshift database and join that with a Mongo database and something else, the no code explorer cannot help you there because, as I mentioned, there's no support for joins. And so what you need to do there instead is publish virtual data sets instead. So use SQL Lab. I showed off that right join example, right, where I was joining two different data sets sourced from CSV. So you can kind of take that exact example and mind map it. So you would basically need to transform the data set first. So write a query that does the transformation that you want, publish that as a virtual data set, because a virtual data set at the end of the day in Superset is just an arbitrary SQL query. So you write an arbitrary SQL query that you want, do whatever crazy type of joining and federation that you want, publish that to Superset as a virtual data set, and then from there on, you have a nice clean room again to build charts. But yeah, there's no kind of support for building complex joined tables or joining data sources in Superset. You kind of need to do that yourself.
Got it. Cool. I think that is it. If any, did we just get, okay, we just got another one. So we often see issues connecting Presto over SSL. In the community, we also see users facing the same kind of issues related to certificates. Is there any way to update the documentation with SSL connection for Presto? Currently, we are disabling the SSL validation to connect over.
Yeah, great question. Even yesterday, someone was talking about SSL for a different database. I think it was Vertica. This is like, because we support the community supports a lot of databases. There's different levels of support sometimes. So for things like SSL, I do definitely agree. That's missing documentation. I mean, one thing you could do, I've definitely opened an issue. We have a Superset Slack. You're welcome to reach out to me there. I'm happy to help work with, again, I'm new to the Presto community, but we have some Presto experts internally at Preset, and I'm sure they would know the answer in a heartbeat. So I'll definitely work with them to update the documentation. And you can also reach out to me personally in the Superset Slack or just via email. I'm just Srini@preset.io. So yeah, I'm happy to help there. This is just one of the, I guess, the downsides of open source sometimes is people don't document things. We do have a lot of people that use Presto with Superset through SSL. It just hasn't been documented. So I'd love to make that happen.
Great. All right. I think that's it then, unless we get a last minute. So while we give folks one more minute if they have a question, do you see my old and today's recordings will be available at YouTube?
Yep.
All right. So old and today's recordings will be available on the YouTube channel. As soon as we get this cleaned up and uploaded, you'll get a notification that it's available on the YouTube channel along with all of our other meetups. And again, just a reminder, join your local meetup. We'll be trying to do a lot more in-person stuff this year and would love to meet the community and meet everybody face-to-face as much as possible. Okay, we just got one more question. I think we'll end on this one. Okay, it sounds like it's a question about a bug. There's a bug we noticed in Presto over Superset. The decimal values were treating as string in Superset. Any workaround for that without casting?
Yeah, I was going to say casting. So that's what I did, because when I was using CSV files, you can only do variable characters, strings, and you have to cast it yourself. Workarounds, I mean, if it's a bug, let's fix it and open the issue, and I'll work with my team internally. We do a lot of contribution to open source Superset, so and we have a lot of, as mentioned, Beto, he's a huge Presto nerd, so let's fix the issue. If you want to, I can dig up the issue, or if you want to open a new one, please do, and we look at all of them. We can't fix everything, but I think this is definitely one that's a no-brainer. So yeah, happy to help fix it somehow. Cool.
All right, with that, I think I'll call it. So Srini, thank you so much. This was such an awesome overview of Superset and how it works with Presto. Really excited to see what everybody starts doing. And I think Srini mentioned the Slack channel for Superset. Join it. It's an open source. We're very close friends, of course, with the Presto community and the Superset community. Seb, thanks for being available to answer any Presto related questions. Always great to have you. And thanks everybody for sticking around with us. And looks like Srini just dropped the community, the Superset community page in there. Awesome. And keep keep radars on. We'll be announcing our next meetup soon. Look forward to seeing everybody then. Thanks, Srini. Thanks, Seb. See everybody next time.
Absolutely. Thanks for having me. Have a good rest of the day. Bye.
Thanks, Ray. Bye.